This is what was at the center of my thinking in all the standards work that I did. And it fortunately became contagious. And this will help you understand why the standards are the way they are. So I'm going to take a little detour to ask this question. In the California tradition, it's multiple choice. So, you know, obviously, number 4 is the answer that's supposed to be correct. I watched hundreds of hours of videos of Japanese teachers, American teachers, German teachers teaching 8th grade in algebra. These are at middle schools, not at high schools. And it took years for me to finally see the obvious. It's one of those, American classrooms, even our best teachers, their goal is to teach the kids how to get the answer to today's problem. And that goal is the same if you're a traditional teacher or if you're a progressive teacher. It's about getting the answer. In the Japanese classroom, whether you're a good teacher or a bad teacher, and they have the same distribution of teachers as we do. Every kind of people, really pedagogic geniuses to dullards teaching, just like we do. I mean, it's not a big difference in the pedagogy from the point of view of the teacher's capabilities. Their goal is different. American teacher, how am I going to teach my kids how to get the answer to this problem? The Japanese teacher asks, what's the math they're supposed to learn from working on this problem? How am I going to use this problem to teach that math? Answers, just so you don't quote me wrong, answers are essential. Correct answers are essential. This is not a talk against answers. But they're part of the process, they're not the product. The product is the math the kids walk away with in their heads and their ability to do stuff. Wrong answers are part of the process too. Time and again in the Japanese classroom, you'll see, Jen discovered an approach that doesn't work. Jen, explain your discovery to the class. Jen explains the discovery to the class. Does everyone understand Jen's discovery? Now let's all figure out why it didn't work. Jen, did you figure out why it didn't work? Let's figure it out. When you do, it's actually often easier to get to the math figuring out why an approach didn't work than why an approach did work. There's another reason they do this. We had a Japanese educator that we were working with, not for the standards, this was an earlier project, who criticized us for treating this situation as Jen's problem. Something wrong with Jen, need to diagnose and remediate. That's not the first reaction in a Japanese classroom. First reaction is, Jen is the canary in the mine shaft. That approach that Jen discovered, any one of you might go down that path tomorrow or next week or the week after. And what's your name? Parker, he was like this. He got the answer real quick. He might have got the answer like that because he made lucky assumptions. They might be lucky assumptions he learned last year or whatever it is, but his understanding is not very robust. Next week, I'll give him a different problem. He'll make those same assumptions. They won't work for that problem. He'll be confused, and he'll wind up where Jen is. So I'm treating Jen as a symptom of the whole class, not as an individual psychological problem. And so for Parker, what I'm doing is making his understanding more robust and deeper. So there are 3 necessary things we need to do with a math problem. Answer getting, we're not saying that's bad. And in the SERP work, Jen was involved in the early days, in the SERP work, one of the things we've discovered in trying to figure out why kids have problems with word problems is that they don't even bother to try to make sense of the problem. They rush to answer getting. They immediately start doing experimental arithmetic with the numbers, and they do the easiest. The strategy is really something that works pretty good in elementary school. You look at the numbers and you do the easiest arithmetic you can do with those numbers. And if it comes out even, stop. If it doesn't come out even, try the next easiest arithmetic. Keep doing it until it comes out even, then stop. That'll get you proficient on the CST in elementary school. But it trains them not to make sense of the problems. So we've devised techniques, I'll show you some, for delaying answer getting. And here's what happens. I'm a teacher. You're all over the place in terms of your preparedness. I have to keep going. I got a pacing plan. I got to finish the book, whatever it is. Not even half of you are prepared for today's lesson. So I got a problem that you got to get the answer right to. If I think my job is teaching you how to get the right answer, there's a lot of different ways to teach you how to get the right answer, a lot of different ways to get the right answer. One of those ways is for me to teach you some math you don't know already, and then show you how to use that math that you're still not sure you know, you're not too sure of, you've never used it before, you're an absolute rookie at using this math, a beginner, to show you how to use that math you just learned, and you just forgot, you just remembered again, to get the right answer. Some of you will pick it up right away. Some of you will struggle, get it a little wrong. This sounds like a classroom management mess. I'm not going that way. Another way I could do it is to show you how to get the right answer with math you already know, that's more reliable, and a few memory aids. That sounds better. I can keep the class together better. You can be producing right answers before the bell rings, and since you already know the math, it'll be more reliable. It's incredible when you analyze our textbooks, and it's even worse when you look in the classrooms, what a high percentage of what we teach kids is not mathematics, but answer-getting techniques. So it's a curriculum problem. The reason, mile wide, inch deep, we're teaching more topics than anyone else. We spend less time per topic than anyone else. I'll come back to that. Okay. But the kids are habituated to answer getting. To quote my own daughter when she was in high school, "Daddy, I don't have time to understand it. I just want to get it right on the test." And she went elsewhere. That's what she said as she was folding her book, taking her papers, and leaving to go call one of her girlfriends. A month later, she said proudly, "I know how to get a B in a math class without learning anything," which she did the rest of her career. She went on to college. She's successful and has 2 wonderful kids that are my grandkids. So here's that question, the difference. How can I teach my kids to get the right answer? How can I use this problem to teach the math they're supposed to learn from it? So let's just look at some examples. We've all taught adding fractions with unlike denominators. We all have methods. This is a common method. You may not recognize the name, but you'll recognize the method. Works like this. You draw the wings, and then you draw the body. You draw a plus sign for the antenna to remind you, a multiplication sign for the tail. Then you multiply on the wings. 4 times 1 is 4, you write it down. 3 times 3 is 9, you write it down. 9 plus, I remember, 4 is 13. Down here, I remember to multiply. 4 times 3 is 12, you write it in the tail. Answer, 13/12. Correct. Works every time. What the hell does this have to do with algebra? This is how the kids you're getting in algebra got past the fractions test when they were in 6th grade or 5th grade. But when you get them, they don't know fractions. How did they pass the test? They passed the test doing it like this. So this is not mathematics. This is answer getting. This is clutter in the curriculum. This takes 3 or 4 days to teach, gets them past this year's test or this month's test, wastes time. To teach them the mathematics they're supposed to learn when they're adding fractions with unlike denominator would take longer and would be harder for them, but you'd be teaching them algebra. Real method. This is algebra. You know, first out or inner last, everyone does it. Not you. It's faster and more reliable than teaching that this is an application of the distributive property. Because to apply the distributive property, you have to do it once, and then you have to do it twice. And the second time you have to do it 2 times, because there's 2 terms. The FOIL method works all chapter long. Next chapter, you have to multiply a binomial times a trinomial. What happens to the FOIL method? Distributive property still works. The way the distributive property works with polynomials, it's very deep, and it turns out to be where integration comes from when they get to calculus. I mean, it's all over the place. It's as the foundation. Canceling. So we all tell them, kids, you know, it's nothing wrong with the word cancel. It's casual. You know, this x cancels this one, this x cancels this one. There are 3 left, so the answer is x cubed. That's correct. What do they do? Here's you have x fifth, this one, this one. They all cancel out. Answer? 0. About half the kids pick 0 on a standardized test for this. It's on most tests will have something like this. Why are they saying 0? It's just a procedure. They don't understand the meaning. They should look at this. Anything times its inverse is 1. You don't even have to do anything. If it's the same on the top and the bottom, it's 1. So what's canceling really about? I'm not against using this word, but they should understand what it is. X over x equals 1. It's the identity element for multiplication. The reason I went through all of this is, you know, the mile wide, inch deep, we all hear that and we think someone's doing it to us. But one of the things we need to do is think, I'm doing it. All of us are doing it. Teachers are doing it. Principals are doing it. Districts are doing it. Textbooks are doing it. Tests are doing it. Standards are doing it. But this is how teachers do it. All these things, canceling isn't math, so you added it to the curriculum. FOIL isn't math, you just added something to the curriculum. Most of the time, you're not only adding, but you're leaving out the math. Teachers have their part in making things mile wide, inch deep, and mainly it comes in the form of methods for answer getting that avoid the math or hide the math.